Welcome guys back to this YouTube channel. So we have another problem in front of us here, which is dy dx divided by dy dx minus y equals xy square. So we have to solve or simply evaluate. So now, if you can remember or recall our previous videos on Bernoulli's equation, we say that Bernoulli's equation can be solved when a differential equation given is in the form of dy dx plus py equals q times y raised to power n. Right? Now, if you can look at this differential equation given here and the differential equation given here and the general form of Bernoulli's equation, we can see that they are actually in matching form. So that means if we have a first order differential equation in which we have y raised to power a factor or a number, then we evaluate using Bernoulli's equation. So evaluating using Bernoulli's equation, how do we solve? So the first step evaluating using Bernoulli's equation is to divide through by y raised to power n. So y raised to power n here is what? Y raised to power 2. Y raised to power n is equal to y raised to power 2. That means n is equal to 2. So we have dy dx minus y minus xy square. So dividing through by y raised to power 2, we have y raised to power 2, y raised to power 2, y raised to power 2, right? So we have y raised to power 2 times dy dx minus, so y divided by y raised to power 2 simply have 1 minus 2, that's indices form or law of indices, we have equals to x. Now, rewriting this, you can simply say y divided by y raised to power 2 times dy dx minus y raised to power minus 1 equals x. So our second step is to multiply through by 1 minus n. Now we said our n is equal to 2 because comparing this with the general form of equation of Bernoulli's equation, n here is equal to 2. So 1 minus n is simply 1 minus 2, which is minus 1. So multiplying through by minus 1, we have minus 1 times 1 over y raised to power 2 times dy dx times minus 1 times minus y raised to power y minus 1 y raised to power minus 1 equals minus 1 times x, which gives me minus 1 over y raised to power 2 times dy dx plus y raised to power minus 1 equals minus x. Then after that, our last step is to say let this be equal to dz dx, right? And let this be equal to z and this be equal to q. Now, why we are assuming this, so we can easily represent it in a simplified first order form, so we can solve by integrating factor method. So my q here is minus x, right? So we have dz dx plus z equals minus x, right? So now we can simply solve using integrating factor method. So comparing this, solving using integrative factor method, first we need to identify my So how do I identify my integrating factor? So since the general form for solving integrating factor says dz dx plus pz is equal to q. Now my q is minus x and my p is 1, right? So my q is minus x and my p is what? 1. So using integrating factor method, my p is 1, and integrating factor, I've identified my integrating factor. We said integrating factor is exponential of the integral of p dx. So which is equal to exponential of the integral, my p is what? 1 times the x, right? So integrating the x, which we just simply have x, right? So this is my integrating factor IF. So now, because we're basically solving using the integrating factor method, so our next step is to multiply through by my integrating factor. So multiplying through by my integrating factor, we have exponential x times dz dx plus exponential x times times multiplying through by this factor times z equals minus x times exponential x. Now, if you can recall our integrating factor method, we just simply take my independent variable and my integrating factor. So this can also be written as the derivative of my independent variable, which is z, and my integrating factor, which is exponential x, which is equal to minus x times exponential x. So now our next step is to integrate. So we integrate this and integrate this. We have z exponential x is equal to the integral of minus x exponential x dx, right? Now, taking the negative sign to the other side, this is minus integral x exponential x dx. Now, we simply have, now how do we evaluate this integral? So since we have two functions of x, this is x and this is x, now it says that when we have two functions of x integrating each other, and we can't actually integrate them any other way, we solve using integral by part. So evaluating this using integral by part, we say let u be equal to x and let dv be equal to exponential x. We all know that the formula for integrating by parts method says that u dv is equal to uv minus v du. So my u, I identified it to be x, and my dv, identified it to be exponential x. So integrating u, that is integrating this u, this is du dx, is equal to 1, which makes du equal to dx. Now integrating dv, remember we differentiate this and we integrate this. So integrating dv, which is equal to exponential x, we have v is equal to exponential x, right? So now we substitute these values into this integral by part method. So u dv, my u is what? X, right? X times my v is what? Exponential x minus integral, my v is what? Exponential x times my du, which is what? Dx. So this is a simple integration, which you can say the integral of exponential x dx, which is what? Exponential x. So this is integral of u dv is equal to x exponential x minus exponential x. So we return it back to this integral here. Remember, we integrated this factor, left the minus sign outside. So returning this factor here, we have z exponential x is equal to minus, open bracket, replacing this with this, we have exponential x times exponential raised to power x minus exponential x, close the bracket. So multiplying through by minus sign, this is minus x exponential x plus exponential x plus c, right? Do not forget your constant because we just finished integrating. So what do we do now? So dividing both sides by exponential x, we have z is equal to minus x exponential x divided by exponential x plus exponential x divided by exponential x plus c divided by exponential x. So we have z is equal to minus x plus 1 plus c exponential minus x. Because law of indices says when this is going up, it becomes minus. So now, if you can recall, we said, if you can recall from when we drifted from this to solve using integrating by part method, we said this is the z dx and this is equal to z. So meaning that z is equal to raised to the power minus 1. So since z is equal to raised to the power minus 1, we place it back into the equation. We have y raised to the power minus 1 is equal to minus x plus 1 plus c exponential minus x. So by final answer, you can actually leave it like this. So you can say y is equal to 1 divided by 1 minus x plus c exponential minus x. Thank you guys for watching. Please subscribe.